Hello everyone, now let me introduce the first part of the project 2. This is a common source MOS amplifier using a resistive divider bias. Here is the result of running this simulation circuit. We can see that the output voltage is about 116 milliamperes and the voltage gain is about 11.62 times, which is 21.2 decibels. In the next page, this is a comparison between the calculated and simulated results of the circuit. Summarized in the following table, we can see that all the data meet the requirements of the task. The gain is greater than 20 decibels. The output resistance is less than 200 ohm. The input resistance is greater than 500 kilo ohm, and the frequency response is flat within 1 MHz. Also, the errors are within a reasonable range. That's all, thank you.
A common gate amplifier is often used in some applications where a low input impedance is required, like RF systems. This is my circuit design. I add a resistor in parallel with the source to reduce the input impedance, and a capacitor in parallel with the drain to meet the bandwidth requirements. This figure is the small signal equivalent circuit. Here, I assume that RDS is very large. Based on this, the results are shown. Then I design circuits to test the input and output resistance, and the simulation results were consistent with the theoretical calculations. Next, based on the required bandwidth, I selected a 0.07 nanofarad capacitor. The test results were close to the calculated values. Finally, this table compares the target values, calculated values, and the simulation results. All parameters meet the expected criteria.
Now I will briefly present our project on a common drain amplifier designed for this course. The common drain amplifier offers two main advantages: high input impedance and low output impedance. First, design the classical common drain amplifier circuit and then use LTSpice to design the circuit diagram. Then analyze its small signal equivalent circuit diagram, analyze the DC operating point and the values of each parameter. In the simulation, we can see the amplification coefficient is 0.915 and the capacitor is 7.95 NF. Next is input impedance and output impedance. Finally, we can see all the values of each parameters and its target values, calculated values, and the simulated values. Most of the parameters meet the requirements. Only the amplification coefficient is slightly away from the target. The reason is that in order to meet the requirements that the output impedance is less than 100 ohms, the value of width to length ratio cannot be too large. Otherwise, the short channel effect will be exacerbated. As a result, the amplification factor is limited to around 0.92.
This slide shows the combined result of all the three amplifiers. We can find out that both the common gate amplifier and the common drain amplifier perfectly meet the design requirements. Meanwhile, the common source amplifier has only 6% error percent from specification and simulated results, which is acceptable. This slide shows the advantages and shortcomings of each amplifier. And this slide shows the common simulation of each amplifiers. Common source amplifier is suitable for applications requiring high gain and high input impedance, such as audio amplifiers. Common gate amplifier is suitable for RF amplifiers, and common drain amplifier is suitable for buffers and drivers. That's all of our projects. Thank you for listening.